Yeah. So today we'll just try to focus on this section only. Okay, not do other things. So we can see. And the plan is to exercise. Yeah, hopefully I'm audible. You can tell me. Exercise 2.2. Okay. And this is challenges and thrills. Okay, just CNT. Okay. So some basic notation, even though I'm not going to go into the section, but just basic, maybe I can turn on my video. Yeah, some basic notation is that obviously this means GCD, just to set it up so that we all know a GCD of A and B, and use this box which you may not have used before. So for the LCM. Yeah. So these are the two things to begin with. Okay. So let us go from problem number 4. Okay. Even though it's very elementary, but there are two kinds of things. Okay. One is that some problems will be tricky. So you have to think of the right way to arrange things and so on, right manipulations. That's one thing. But do not ignore the problems which look very obvious to you when you try numbers, but then you're not able to prove it. Because learning how to prove some things which look true and also you know are true, kind of learning how to write them is, I think, very important. Okay. So the fourth question is what we are going to start with. Okay. So this question is just saying that show that the GCD of two numbers, the greatest common divisor of two numbers, divides the LCM two numbers. Let's see. Yeah. And also get an idea. Yeah, but so give me a reason, maybe in that case. Yeah, it's always true, but hmm, but yes, that's both are correct. But what's the next? Like all of us know this statement. This is always true. But what is a reason? What's a good reason we can give? How do you write? If it's a, this is saying if it's a 5 marks question, how do you write it? Yes, that's another way to say it. Maybe. Okay. Yeah, so we want to, so first let me just say that this is the same question as showing that the LCM by SCF is an integer, right? Is an integer. Or let me just write K. Okay, I hope everybody sees that. That's the meaning of this dividing this. Okay. So now the reason, so Ishana, you're saying, okay, so you're saying LCM is uh, oh, so you're saying that LCM is, okay, so you're using some idea. Okay, LCM is the product, right? Yeah, LCM is product of the two numbers times H. No, the LCM times HCF is product of two numbers, right? Right. So let's just go back to the old note, to the new notation. That's why we have set the notations. So you're saying this times this is equal to AB. So then you want to say that this times this divided by AB is an integer. No, not just this. In fact, you will need to divide by another one, right? Yeah. Good. This is equal to this. So why is this an integer? Okay. Okay. So that's okay. That's right reasoning. And both of these are integers because SCF is a factor of both the numbers. So obviously it divides both the numbers, and so square of the SCF also divides the number. Fine. So this is certainly a reasoning. Okay. Is everybody fine with this? Anyone has a different reasoning? Yeah. Pragdish, Nagesh, if any one of you have a different reasoning. It looks like a very simple, innocuous question. Okay. All right. But now, if I know this is not there, this is not an official question, but I would like to ask this. Obviously, we understand now three numbers. It means that you have to take the divisor which is common to all three, and you have to take the greatest such. You can think of it in that way, simply. And then you have to take the least common multiple of three. You guys would know this better than me. You've done practice calculations in just younger grades. This thing. Now I'm asking this question. How would you prove this? Let's see. Yes, so we have to prove this thing that GCD of ABC is, so I should just write show, right? We want to show this. The GCD of three numbers divides the LCM of three numbers. Let's see, can we use the same method or do we need to? LCM of A and B is A into B. No, we did not use that. We said that the LCM times HCF is A into B. I think that's what you meant. Right. Yeah. I mean, so I shouldn't say LCM times SCF. I should say LCM of A and B for two numbers times SCF of A and B for two numbers is equal to the product. But then isn't that better? It's only better. So then what would, so if you just continue, so you were saying that you want to use the same thing again. It's not this. Okay, maybe. So you're saying that everything rests on this. I mean, I'm not saying you're saying, I'm asking, okay? In the sense that, yeah. Okay. So now let us just focus on this. Is this true? Is this true? Is that equation with the question mark, is that true? Now this, I need an answer very quickly because you see, this is just something you can just take three numbers and try and tell me. Okay, let's see what others are saying. So if you've taken some kind of number, take some other kind of three numbers and try. Come on, everybody would try this. So someone would get, if everybody gets true, then I will say it's true, maybe. Okay. But someone should get that it's not true if it is not true. So what is your, why are others not try? Okay, no, have others got any example? 369, yeah, so you also got some examples. So that's it, you see, it's not true. So what is the GCD of 369? It's just 3. But the LCM is not too much, right? The LCM is not too much. It's 18, perfect, yeah. And this is the product, but yeah, this is it, but the product is very big. This is, so 3 into 18 is 54. 9, 6, 54. 54 times 3 is 162. Difference, okay? Not true. Not true. Okay. So now what is the next step? What should we do? Should we go and do this problem further? That's one thing. If it's an exam, you should do. But now one should question our understanding of this. I mean, from a class perspective, I'm saying that we should question our understanding of this. Do you guys agree? Right? That is the thing. That question one can come later. Okay, two things here. So we have to question that. And just to say a side point, this understanding of GCD and LCM and how they behave, this is all you need to do number theory in elementary level, and later this will help you. Just this will be make things comfortable, and you can just progress miles and miles, fold and folds. This is the foundation that you should have, this intuition. So let us come to why, and if you understand why the two variable case is true, you should really understand there is no way you can make a mistake with three variable case. Okay, obviously we don't understand everything when we know it. So let us understand that thing. Okay. So that's what's coming out, and you can just look around. If you look at the Olympiad questions, or even some took a test of mathematics for ISI, if you look at that, LCM SCF is filled with this kind of identities with LCM SCF and so on. Okay, so prove that product of two numbers. This is obviously a fact that we know from 5th grade, but let's see how we prove it. It's equal to SCF. So read that as SCF. Okay, I'm writing this so you get used to this kind of notation. Let's think of a way to prove it for two numbers. So anyone? HCF as L. Okay. Good. Okay. Yeah, cannot have anything further in common, A and B. Perfect. So this is okay. LCM of A and B. LCM of A and B. Say, can you say this again? L into M into N. Why? Yeah, so you're using that kind of, yeah, that's good. That reasoning is perfect. There's no problem with that. So, but let me just write it a little bit more. Yeah. So least common multiple, though, if you think about it, it's not completely rigorous, but it's okay. It's okay for all purposes. I say, if you write this in an exam, it's fine. So no, so I'm writing this wrong. Sorry. So you're going to take the LCM of these two things, and yeah, but that's even you can say as a property that you can take out the L, right, from this, and then yeah, these two numbers are co-prime, and for co-prime numbers, the LCM is the product. Okay, and that again is it's easy. So, amen. Yeah, and then one can check, yeah, that L, this is L, and this is M and L, and the product is ML and L. Okay, so this is all right. Any doubts? Anyone else with this proof? Yeah, this kind of yeah. Any questions? Yeah, so this kind of thing always works. Say if you just go forward with these simple things, it usually will work. Yeah, that's nature. So now, can anybody think why does the same reasoning, we know that it is not true for three variables, but then why, where will you get stuck in this reasoning when you apply it for the three variable case? Yeah, so again, if you take this as L, right, take this as L, then what happens? Yeah. Yes, I mean, yeah, so they will not be co-prime to each other, right? The total thing will be co-prime. So I mean that maybe that's what you meant. So let me see. So this is the thing. Yeah. So now, yeah, now you should explain because I've put the notation. So what can you say about this LCM? So certainly we can pull out the L. There is no problem with that. Now, if there are these three numbers which don't have any common factors, okay? But so why is the LCM not the product? So certainly the LCM is not more than the product, but even if it is the product, still it does not work. Hmm. That's right. Yeah. So here maybe you should say that you shouldn't. Okay. If you say they're co-prime to each other, that's not correct. In the wording is not correct. Yeah. You say that they're simultaneously co-prime. right? Means all three taken together are co-prime. Now you can put any word there simultaneously. But to each other, they are not co-prime. And that is the reason why the LCM is okay, is not working out. But you see, so certainly the LCM of this is less than this. Yeah, it's going to be less than it. Certainly MNR is a common multiple, right? The LCM is less than it, or less than equal to it. They can be equal, right? If all three are co-prime, then it can be equal. But even if it is this, still it does not work, right? Because still I feel, yeah, if you have this MNR L, right? Then also it does not always work. Obviously, there's some cases it will work. Problem is there's an L cube on this side. On the left hand side, there's an L cube, right? ML, NL, RL, there's an L cube. And the LCM is less than this. So even if you make it, this still it is less. Right? Still this is less. And if L is more than one, which is the, if you see in that kind of examples, there is a problem. So we in fact have some better these things, right? We have some better understanding of this, that this is always less than this, at least, right? Which was to be expected. Okay. So are there any questions? Good. So now you see this can be fixed. Okay, this can be fixed and made into questions, but let's not get into that for now. You will, as you solve more exercises, you will see. So I can erase this. Now you come. Now we go back to thinking about this this thing. Yeah, let's do this because this is where we are learning these things. So let's go back to thinking about this thing. So please think. I'm just erasing this. There is in fact a very simple reason that one could have given for the two variable case that will immediately work. But let's see. We are not looking for the simplest reason. We're looking for a reason first. You see, that's such a simple statement, right? Three numbers, when you take the GCD, it divides the LCM of three numbers. Yeah, I hope it's correct. It's just correct, right? And then we should be able to prove it. Because now we don't have the identities, at least we don't have any simple identities that we know. So how are we going to prove it? So, so if the LCM, so let's say LCM and SCF. So I'm going to denote this, let's say for a moment by D. Okay. What is the meaning of D? Yeah, D is something that divides a Oh, wait, whatever. Huh, it's fine. Sorry. D is something that divides B, and D is something that divides C. That's the meaning of D, right? Okay, that is, I mean, the largest such D is the, yeah. And now if this is L, then what similar thing can you say about L? Okay. So now what can we say? Yeah, right. It's just right in front of us. I mean, just look at any one of them. D divides L. Right. See, so they are simple things, but so this is what we learn. Okay. Right. Yeah. In fact, I mean, obviously here you have D cube divide ABC, right? But then I don't know, you cannot use that. Yeah. So, anyways, these are the things. There are several identities with these things, but yeah, let's move on. There are many interesting things. Yeah, but maybe there is one view which is very essential, I feel, and so I may miss it later. So this is the right time I feel which I should say. There is one very nice way to view GCD and LCM, which works in useful in many problems as I have experienced, and that is so view of GCD and LCM via prime factorization. So anyone has thought about this? So if you take a prime number, any prime number p, okay, if you take p to the power 10 and p to the 8, so then what is the GCD? Right? And then LCM is p raised to 10, right? And so do you see something, right? There is something going on, right? Now let us think, and now let's say now we are going to use prime factorization. Every number can be can be prime factored. Okay, that's not a trivial statement. If you try to prove it, you will see that it's a lot of things to be done there. But roughly we all understand because we keep factorizing and it stops, and so we know, right? So if you take any number a, and let's say that we are factorizing it. So let's for the moment keep some numbers here, and let's say p2 to the power 7. Okay, and now b is again, let's say p1 to the power 5 and p2 to the power 11, right? And let's just keep it like this. Okay, so now what will be the SCF? Right, 5 and p2 raised to 7. So what is happening? We are taking, so it's one prime at a time, right? We are taking this prime and we are focusing on this and calculating the SCF. And then the next one and calculating the SCF. That is all that is happening. Right? And then you obviously multiply them. Yeah, multiply the SCFs. Okay. And what are we doing? We are picking the minimum, right? We are picking the minimum of 10 and 5. And then again, the next one, we're picking the minimum of 7 and 11. And this is a feature that extends for 3 numbers also. Is that right? Yeah. This is something that will extend for 3 numbers. Yeah. So for example, so it could happen that P1 doesn't have, so C doesn't have P1. So in that case, just formally write 0. No problem, right? And let's say it has P2. It may not have, it doesn't really matter. It doesn't have a write 0. But you symbolically put all the PIs so that you can compare, you can just normal things. Understand? 9. And there could be a P3, it could be just P3. And so here you just write it if you need to, formally. So it's not there, but you write it. Again, you will see the LCM and SCF. So the LCM, so the SCF here, the GCD would be just to pick the minimum prime, the minimum power of the primes, right? Of each prime, minimum power of each prime. So the GCD, so computationally speaking, this is a bad way to do it because factorizing a number is not so easy. But symbolically speaking, and to find formulas and closed expressions of many problems, I will give one such, which you can try. This is a very nice thing. So what you do, you just take the minimum. Right? It's just like having 3 sequences, 10, 7, 0, 5, 11, 0, and 0, 9, 1. This is 1, right? And you pick the minimum of each term wise. Right? That's all it is, right? There's minimum of the power and similarly minimum of the powers and similarly. Simple stuff. There's nothing really fancy in this. And similarly for SCF, sorry, for LCM, it will be the maximum. So is it fine? Do you guys agree? Yes, exactly. And this is also the standard proof in the sense that this is also what I had in mind. Obviously, Ishana's proof was different, but this was also what I had in mind. Okay. So yeah, this is a good way to work with LCMs and SCMs, especially when you're computing some expressions. But don't remember what I'm trying to say. It doesn't really depend on the problem, but this is a good thing to have. Okay. Okay, so then I think this is easy for everyone. So now the good questions that come out of it is like this. One particular application which I can give right away, which I know right away, is this. But I've used this several times in several questions, but I don't remember the identities and whatever they were, so I can't give them. So if quickly speaking, we can say this. So find, this is a good question. This is not there in challenges and thrills, but this is there. I remember it being in some number theory section somewhere. So anyways, and it's just the question you can ask. Find the number of pairs of numbers a comma b, okay, such that just a minute. Yeah, so let me just ask this first. Such that the GCD of A and B, okay, so I should say GCD. So if this one, I just mean pairs A comma B. So this one doesn't mean GCD. Okay, this one just means pairs A comma B, this pair of numbers, so that the GCD of those two numbers is, let's say, 75. Yeah. So how do you find these numbers? Find the number of pairs, not finding the numbers, which is how many pairs are there, how many pairs of numbers you can take, and so that the GCD is 75. Yeah. So, and does everybody see that it's infinite? Okay, not any two multiples of 75, because that may give rise, the GCD may increase. Yeah, so yeah, that's straightforward, right? So you could take one of them to be 75 and the other one you can take anything. there's no chance GCD becoming bigger. Okay, so in particular, we are not using anything fancy, like you take in all the prime multiples and so on, fancy things, because then why are there infinitely many primes? Well, that's a standard thing, but again, not needed to use. That's the point. Okay? It's a basic thing, and it's very important because this means that this will can be hold true in other places where there is no concept of primes. So it's better to keep things if one can see it. So this is not a good question. Okay, so it's okay that you guys have good basics, so it's okay. So for you, it's not a good question. But let's come to this maybe. So now if I say that, let's say the LCM is also there. So let's say that the LCM is 100. Now, how many such pairs of numbers are there? Yeah, this is something that one can think about. So for two numbers is actually not difficult. You can do it by any way. I mean, so just see, what is this? Yes, and I'm surprised that it took so long for everybody to see this, because this is what we have been discussing, right? Because the GCD has to divide the LCM. That's what we have been talking about, right? Since the beginning. So it's obviously not possible. So we have to change the number. So these are the things which you have to just wake up and just quickly take it, catch it. Yeah. And then let's try this one. This is fine. So let's try this one. So that's the thing you have to see. So it's infinite and zero and everything in between. So uh, those are also possible. Infinite and zero are also possible. Okay, so that question number 15 in challenges and thrills is like that. Yeah, I did not know this. But see, yeah, this is a two variable question, and this doesn't need the minimum maximum interpretation. This can be done directly, and so can question number 15. So we have moved to question number 15. This is similar. Either ways, yeah. Numbers are different questions. So that's how it is. Through this organically discussing, we get to this things, other things.
So I think A and B will be 9 and
9 and 25. Is that the only this thing? So A 9 and 25. No, 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 no. How is GCTV 75? Yeah, the LCM will be no, whatever. Okay, let's see. So 75 and 225. The GCD. Oh, so that's so that's because I have given a bad example. Okay, all right. So yes, yeah. So that's right. And let's try to prove that. Then I'll change the example. So these are bad examples that I gave. I didn't notice that 75 divided to 25. Yeah. So well, but this is an interesting thing that if the GCD is 75. Okay, no. So 1 minute. Let us see. Yeah. No. So let's not get too ahead of us. No. So why is this so this certainly works, yeah, because GCD 75 and 225 is 75, and the LCM is 225 because one divides the other. There's no problem with that. But then why is this the only solution? Yeah. Mhm. Uh, okay. That's right. Right. That is certainly correct. So the reason is happening that is because B by A is a prime number, right? I mean, 225 by 75 is a prime number, right? Maybe that's the reason, right? Yeah. But still, let's do the factorization and let's get it more directly. So this, as we have seen, if you take the, because see, I mean, when you, so maybe that's a better good way of edition, and then it's a sort of unorthodox way. So we should see that in the sense, if you take the multiples like 25, 75, and 45 is there. 45 is certainly there. Yeah, so I missed that. And then there is 225, and 15 certainly, right? And then are there more? There will be more, right? There will be one more. Or is it? No, so there are no more, right? Five. The basic one I missed, right? Five. Right. So there is five as well. So all these things. So, well, you see, now if you're taking the LCM and you're getting 225, it means that the two numbers you're picking must be from this set, right? I mean, because you have to pick the LCM of two numbers is 225, then the two numbers have to be divisors, right? Then you have to pick two numbers from this whose GCD is 75. Right? We have to pick two numbers from here whose GCD is 75. So obviously 225 and 75 you can easily pick, but then the LCM has to also be 225. So if we do by this method, then so to get 225 as the LCM, you can pick like so why can't you pick 9 and 25, something like that? But then the GCD becomes small, right? Yes, that's the right. Yeah, that's the right reasoning actually. Yeah. So what you need to pick is a multiple of 75. I mean, the options that you have are multiples of 75. Do you see? Right. So they have to be among these two. So it's a clear cut thing that there is no this is the only two options. Right? Because you need to pick multiples of 75 because the GCD has to be 75. Right? And so why is there only one multiple of 75 available? Because 225 by 75 is a prime. Is that right? Yeah. Yeah, because this 3 is the only possibility. So the only multiple in this list will be that times 3. If it was if 225 by 75 was some composite number, then you could have several multiples of it and then you could have choices. Okay. So that is the thing. Yeah. Right. So that is the thing. But then in general, that's maybe not such a good way to, yeah. So how about we take like 75 times 10 and let's take 750. So in this case, what could we say? So I mean, again, we can do it in a similar way, right? We could take 75 its multiples, which are all divisors of 750, and we could work it out. But it would say it would become a little more ad hoc. What my point of introducing this example is that you take this, and so we certainly have some interesting arguments. That's a very good thing. Okay, so everybody should see that these interesting arguments is what really is the purpose of this class, because when everything is written, obviously also in an organized way we are doing it, that's important, and discipline and so on is there, but there's other ways to see things which you may not think if you're thinking on your own is one of the main things, right? So that is the thing. And yeah, so here what do we get? We get this. So okay, let's try in a descending order only, and we get this. Yeah. And so now how do we do this systematically? Right. So what does this mean? It certainly means that the factors of A and B cannot be outside 2, 3, and 5. Right. So the factors of A cannot be outside 2, 3, and 5. Is that right? So A could be 2 to the power, I'm just writing A1. Okay, so or for the moment we can just take some number, some letters, but later on you would have to go with subscripts because letters, not too many letters. F and then you have G. Okay, and then similarly, you have B, and so for B also we have. So you guys agree, right? And beyond this, there is no need to consider. There's no need to consider 7, certainly, right? Because the LCM will tell you. So this is not E. This is because when it comes to 3 variables and so on, then this combinatorial, combinatorial is problem, right? It means enumeration. And once you can get these problems done, then a whole lot of problems in number theory get solved. Number of devices and not or sum of devices and product of devices and many things are there. And they get, means you may not know the formulas, but you know that you can do it when it comes. So this is the thing. Now, what do we want to say? Yes, so that is certainly, yeah. So we can do that. That is certainly correct. I mean, you could divide that uh, and say. So is that better to do? Maybe 1 minute. Yes, that is no, that is certainly correct. So you're saying you remove the GCD from both the numbers, and then you just left with a simple problem, right? Yes. So, but again, you see, there is a problem with that method in the sense that maybe that when you again go to the 3 variable case, ABC, then you see, right? There is again the same problem. Yeah, again, that method, this taking the common factor, taking it out is again becomes a little bit, you see. But my point is that now if you use this, and that will also work if we just extend it. But since I know this from before, so I'm just saying it in a more, yeah, aggressive in the sense that, yeah, this will work. But the point is that what we just want to say is that the minimum of E and H has to be 0, right? Minimum of E and H has to be 0. Do you guys agree? Because the 2 doesn't appear in the GCD. Yeah, perfect, good. So this is the thing. And then what's the maximum? 1. And so how many possibilities for E comma H? I mean, how many, let's say, what are the possibilities for E comma H? Well, it could be 0, 1. It could be 1, 0. Anything else? There is no other possibility. So equal to what? No, because then the maximum won't be 1, right? And if both are 1, the minimum won't be 0, right? So that is the thing. This is the only possibility in this case. But you see, this will keep working in general. But let's do this first. Okay? So what does this give us? This gives us 2 possibilities, 2 choices. So yeah, just a good old way of counting, right? You're breaking it up into taking care of that. There are 2 choices to deal with that combination of 2s. Yeah, is that fine with everyone? Yeah. Okay. And then similarly for f and I, what are the possibility? The minimum of f comma I has to be, so someone say this, right? And the maximum is also 2. And this, what does this mean? Perfect. Yeah, so this means only one choice. It's a small number, so small gaps. So it's looking like that, but right. And similarly for G comma H, there are G comma J, how many choices? 2 choices. 2, 3 and 3, 2, just like earlier, 0, 1 and 1, 0. So you see, so in total, how many choices will be there? 2 choices times 2 choice, 2 choices times 1 choice times 2 choice. So 4. 4 choices. So why have I multiplied? Someone should explain that. Otherwise, you won't know, right? Then you'll end up multiplying in some place where you have to add. So no, but just why are we multiplying? And you can see this is an efficient method, right? Even if the gaps are large, right? Even if this was 2 and this was 13, well, but okay, because it is a two variable case, then it's two, always at most two choices, right? But in the three variable cases where you will reap the benefits of this, right? One has to be 2, the other has to be 13, and the third one has to be in between. So you would know 13 minus 12 plus 1 choices for the middle one. You see, then it will really come to the here it is 1 and 2. So it's, you will think, but yeah. But first, let's clear this. Why are we multiplying? Right, and each of those will give you different cases, right? Because initially, yeah, and that's important, right? So initially you have like 2 to the 0 and 2 to the 1. This is you starting to make this, and the other starting point is this. Now, whatever those numbers will end up becoming, let's focus on the first pair, 2 to the power 0, 2 to the power 1. Whatever those numbers will end up becoming, they are different right from the start, and you cannot make them same later on. Is that right? Yeah. Each prime is enough to create a difference. Yeah. If two numbers have to be same, then every prime to every multiplicity has to match. Every prime has to match with every power. So if already they are different, like 2 to the power 0, 2 to the power 1, then they will just, they are different cases. They will remain different. Right. So these two, I mean, what I'm saying is that these two, this pair and this pair is, it's a different pair, right? And now, and that's what I'm trying, that's okay, so I should say this again. These two are different pairs, right? And so they will remain different. That is a point. Yeah. And why are the different pairs? Because I mean, this number in the first place does not match with this number in the first place. Yeah. And even if this would have matched, if the second one doesn't match, then also they are different pairs, right? So you will get different numbers. Yeah. So these are the things. And so what are those four numbers? Now, can we say that? That will be good to conclude. What are the four numbers? Because you can build it. So no need to guess. You can guess and check, but we can build it from here and say that will be better. Let's erase this here and write it in a proper way. 1 minute. Yeah, so let me write it as a tree. Let me write it as a diagram. Yeah. So see, initially you have this number that you're making is 2 to the 0, 2 to the 1. And here you're making 2 to the 0 and 2 to the, okay, so this is again not a good way to write it. So it's like this. And here you're started to make this, right? And then comes choice for the threes, right? And so when it comes to choice for the powers of 3, we saw that they are the same. So both have to be 2. So this will just lead to 2. And this will also have to be 2. We saw that from the LCMS information that was the case, only one choice. Yeah, both have to be 2. And this also has the same, but already they are different cases and they'll not become the same anymore. So it's, for each choice in the last step, there are one choice in the next step, but that's what it is. I mean, I could have written it in the same place, but that's the point. And then you can see, now this slightly more interesting. Okay, so some of the things got erased. So G and S, it's already here, G and J, right? So, and that was 5, I think. Right? So it has two choices, right? But I forgot the powers. No, so was 3 and 2. Sorry, yeah, it was 3 and 2. Yes, yeah. I forgot the powers. Okay, so 3 and 2, and so either 3 and 2 or 2 and 3, right? So and the power was 5. So you can see now this may look very childish doing this, but it will make it absolutely clear that this is it cannot be anything else, because there are some variations of this that come where it's not this. It have to multiply and then divide by something or subtract a one. So you have to see. I mean, this if this works, you have to see very clearly. Try to just be patient. Not in an exam. Patiently try to learn. Obviously, you say keep some time for solving problems fast. You get a paper and you solve it fast. Okay, like some IOQM happened or B math happened or whatever. I mean, you find him for all levels, right? JMO, just and just try them. Obviously, I also gave a mock test once in a while. I'll try to give more. Um, so this is a 2 and this was 3, but then the other thing is 3 and 2, right? So 3 and so you can understand 2, and that also you can try. Huh? Sorry? Oh, yeah. This was 1. At the bottom one is 1. Sorry. Otherwise, you can. It's not correct. Yeah. Right. Huh. Okay. And you can see that. Okay. Those two numbers are different, and so they remain different. Okay. So it's just like multiplication. Okay. So this is what we learned for 2 variable case. It's simple. You could have done it by pulling out the GCD and so on. But 3 variable case, you will reap the benefits. I didn't complete the 3 on that side. Do it. Yeah, so now you can, I mean, just take your own numbers and try. I'm not even giving the numbers, but just do it. Okay. Tell me. So you have to tell me next time what numbers you took and did. Okay. Take some, I mean, numbers meaning that choose what LCM and SCF. One divides the other. You have to choose reasonably and try. Okay. And then we can discuss how you did it. So this is just a standard question. It comes in a lot of MCQs at least I've seen. JEE Advanced also it can, I think, but yeah, I don't remember JEE Advanced. Last time I was teaching someone, I think a lot of questions like this were there, and they do it really fast. Yeah, so we didn't discuss many other questions, but we learned a few things. So yeah, it's fine. Let's keep this. Next day, the theme can be, so I'll just stop on time. So next day, the theme can be to have these kind of things, right? N square minus 1 is a multiple of 8. Product of any 3 numbers is a multiple of 6, and other things like this. So there's general features of divisibility, yeah, that occur. Some general divisibility things, general things, yeah. Yeah, that is not specific to any numbers, general things, and still it is divisible by 5. It's general expression. That is what number theory is about, right? You say something general and yet interesting. Yeah, obviously if you become too general, then it maybe there's nothing interesting, but general enough and interesting enough is very is the what number theory